Good morning, everyone. In this class, we are going to discuss about sea waves, tides, and currents. Okay. Ocean water is never still. Its movement is driven by a combination of physical characteristics like temperature and density, and external forces like sun, moon, and wind. We can understand this constant motion through the three fundamental rhythms: okay, the breath, the pulse, and the circulatory system. The breath means the familiar energy of waves on the surface, that is waves, sea waves. The pulse, the daily rise and fall of tides driven by celestial forces, that is tides, sea tides. The circulatory systems, the vast globe-spanning network of currents, that is sea currents, ocean currents. Okay, first of all, the waves. Waves are the transfer of energy across the ocean. Waves are the horizontal oscillation of the ocean surface, primarily created by the friction of wind. Their size is not random. It is determined by three key factors: wind strength, how hard the wind blows, and duration, how long the wind blows, distance, the stretch of open water and the wind travels over. While waves cause water particles to move in a particular circular motion, the wave itself moves forward. Every wave has a distinct structure and measurable characteristics. This is wave crest, the highest point of a wave. And this is wave trough, the lowest point of a wave. This is the wave height from this portion to this portion, this line. Wave height, the vertical distance between the crest and trough. And this is the wave length, distance between two crests. The horizontal distance between two consecutive crests. This is wave length. Okay, this is the structure of a wave. Now tides are the daily rise and fall of sea level. Unlike waves, tides are a vertical movement of ocean water. They are caused by the gravitational pull of the moon and to lesser extent the sun. The moon's proximity to Earth gives it a stronger influence despite its smaller size. The gravitational lens creates a global rhythm. The moon's gravity pulls on Earth's ocean, creating a bulk of water on the side of Earth facing the moon. Okay, this is the Earth and this is the moon, and this is the high tide. Again, this is the high tide, low tide, low tide. A second block from the opposite side is water is pulled away from that area. As the water rotates through these two bulks, we experience a predictable circle. It results two high tides and two low tides. Two high tides and two low tides. Tidal cycle. The period between high tide is approximately 12 hours and 25 minutes. Now, two types of tides: spring and neap tides. Spring tide occurs when the sun, moon, and earth are aligned. Okay, this is sun, moon, and earth are aligned in same parallel line. Okay, it's called as spring tide. Their combined gravity creates higher high tides and lower low tides, resulting in a greater tidal range. Okay, it creates a greater tidal range, means duration, greater tidal duration. On the other hand, neap tide occurs when sun and moon are at right angle to each other. Sun and moon are right angle. Right angle means 90 degree. This is 90 degree. Their gravitational pulls partially cancel each other out, resulting in lower high tides and higher low tides and a smaller tidal range. Okay. On the other hand, spring tide creates higher high tides and lower low tides. On the other hand, neap tide, lower high tides and higher low tides. Opposite, and it creates a greater tidal range, in its case a smaller tidal range, means smaller tidal difference. The subtle influence of orbital paths, the distance between celestial bodies are also affects tidal strength. Tides are amplified when the earth and moon are closer and diminished when they are farther apart. Perigee means the moon's closest point to the earth, resulting in unusually high and low tides. Apogee means the moon's farthest point from earth, resulting in smaller tidal ranges. Perihelion, the earth's closest point to the sun, around January 3, contributing to unusual high and low tides. Aphelion, the earth's farthest point from the sun, around July 4, resulting in much smaller tidal lengths. Okay, this is perigee, apogee, perihelion, and aphelion. Now, ocean currents. Ocean currents are rivers of water moving within the ocean. Ocean currents are the predictable continuous movement of seawater flowing both horizontally and vertically. They are driven by a combination of forces. Wind pushes surface water, gravity pulls water down slopes, water density differences in temperature and salinities cause water to rise and sink. Okay, there are three different combination of currents: wind, gravity, and water density. The language of ocean circulation: the ocean currents from complex systems with distinct components that drive the ocean conveyor belt, also known as thermohaline circulation. This belt regulates the planet's temperature, salinity, and nutrient law. GYRE, GIRI. A large system of circular ocean currents formed by global wind patterns and the Earth's rotation. Stream, a massive body of water moving in a specific direction with high velocity, example the Gulf Stream. And drift, a shallow current that moves due to the prevailing winds, example North Atlantic drift. Okay, this is the diagram. Now, the global exchange of heat, warm and cold currents. Cold ocean currents, warm ocean currents. In terms of origin, cold ocean currents are polar regions. Warm ocean currents formed in equatorial regions. Okay, on the basis of flow, cold ocean currents towards the equator, warm ocean currents away from the equator. On the basis of climate effect, cold ocean currents cools adjacent land, can increase precipitation. Warm ocean currents warm adjacent land, can decrease precipitation. On the basis of location, cold ocean currents are typically on eastern coast of continents. Warm ocean currents typically on western coast of continents. Examples: cold ocean currents, California current and Benguela current. And warm ocean currents examples: Kuroshio current, North equatorial current. Okay, these are cold ocean currents and warm ocean currents. The three rhythms work together to shape our planet. The movement of the ocean are not isolated. They form an integrated system that governs the health and stability of our planet. Waves energize the ocean surface and shape our coastlines. The tides drive the daily mixing of coastal waters, vital for marine ecosystem. High tide, low tide. And currents actually as a global engine, distributing heat and nutrients that regulate climate and support life across the globe. Okay, why the ocean movement matters? Why the importance of ocean circulation? That is wave, tide, and currents. The continuous movement of ocean water has far-reaching implications for Earth systems and human life. Climate and weather. The ocean circulation is a critical component of the Earth's climate system, regulating global temperatures by transporting heat from the equator to the poles. Marine life, currents and tides are vital for dispersing nutrients and the young of many species, supporting the entire marine food chain. Transportation and trade. For centuries, ocean currents have been used to facilitate the movement of people and goods across the globe. Energy production. The immense power of tides and waves can be harnessed to generate clean electricity. Okay, these are four basic types of contributions of ocean circulation or ocean movements. Now, from the smallest ripple to the global spinning conveyor belt, the rhythmic movement of ocean water is fundamental to Earth's climate, its diverse ecosystems, and our own existence. Understanding these rhythms is essential for managing our ocean resources and predicting our planet's future. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.